The kinetic molecular theory is a theory that helps to explain how gases act and the reason they act the way they do. The definition of a theory is just an attempt to explain why we have a behavior or properties that we do. It is based on evidence, and so there's been evidence collected, and then we attempt to explain why something happens. The kinetic molecular theory is an attempt to explain gas behavior, like I mentioned. It's based upon how their particles move. There's six assumptions. First one, all gases are made up of atoms or particles, or molecules. Atoms are single atoms by themselves. Molecules are a combination. So water would be an example of a molecule, H2O. Second assumption is that gas particles are always in constant rapid motion. Third is that the temperature of a gas is proportional to the average kinetic energy of the particle. So what this tells us is that when the temperature increases, the energy increases, or when the energy increases, the temperature increases. And also vice versa. 4 is gas particles are not attracted or repelled to one another. So that means they don't have positive negative charges. They don't want to stick to each other. That's an assumption of this theory also. Fifth one is that when gas particles collide, it's perfectly elastic, which means they don't lose any energy when they collide. And then the last one is that the volume of gas particles is so small that is pretty much insignificant. Now that's a definition for ideal gases. Real gases are what we actually deal with in science, and real gases do not obey two of these assumptions from the KMT. First one is that particles are not attracted or repelled to each other. Particles really do have attractions and repulsions. They have positive and negative charges, and so they do want to stick together. They don't always just float around without any interactions. The second statement that's not true for real gases is that the particles take up no significant space. They do take up space, and so it reduces the space available for other particles. And so those are two statements that real gases do not obey. Now, ideal gases do, but it's not very often that we deal with an ideal situation.